Okay, so yeah, so now this particular call is with with the first two arguments are of type int, and the third argument is of type double. And we saw also in the last class that this actually results in an ambiguous thing. Okay, so why is this ambiguous? Okay, so the reason it is ambiguous is because for the f1 function call here, okay, so there are two, so both of these candidates are viable because you see from 5 can be converted to int and 5 can be converted to double also. Okay, similarly 2.0 can be converted to int and 2.0 can be converted to double also. Okay, so both of these are viable arguments. Okay, but for the first two arguments, f1 has an exact match. Okay, so if you see, exact match is the best kind of match. Okay, and 2.0 is basically a conversion. Okay, so it's a type conversion. So it's a conversion from double to int. So it's an integral conversion. Okay, now for the f2 function, the third argument is an exact match. Okay, so in terms of third argument, f2 is actually better than f1. Okay, but in terms of the first two arguments, there is a conversion. So there is a double conversion, right? So basically, so the first two arguments are a conversion. So you see,
And the first two arguments, the int is getting converted to double, so there is no data loss. So shouldn't f2 be
yes,
called?
but it is a conversion nonetheless. It is not an exact match. See, if you see, it's a type of conversion, right?
Yes, yes, sir. It's a type of conversion, but if we compare between f1 and f2, then f2 is better.
No, no, no. So f2 is not better. You see, there is a floating.
Professor Shorangshu,
Yes.
I would just like to comment on what the student was saying. If you convert into double, it is not right to say that there cannot be data loss.
Yes, yes.
In general, that is not true. For example, because the double is not represented in the integral way at all. That is, if you have 3, to represent in integer, you will actually have the binary representation of 3. If you have to represent it in double, it is not that you will represent 3 and then 0.0. There is a exponential mantissa format where you will take logarithm in certain way and represent that. So for all integers, it cannot be guaranteed that if an integer is n, then the double representation will be n.0.
Right.
I mean, there are processors where say if you represent 3 in a double, it could turn out to be 2 and then a very large sequence of 9s. Right. So there is a data loss. There's a possibility of data loss always, which the compiler considers. Of course, it is very explicit when you do the other way around, double to int, because there you are coming to from a larger data type to a smaller data type. So 2.5 will have to be represented in int as 2. But the other way too, the compiler considers that there is some data loss that is possible. Okay, so that is the reason.
Right. Yeah, and yeah, so there is so on this note, there is also in your assignment there is a question on this. So you should. I hope you are solving the assignment already. Okay, so go ahead. So now you see. Okay, so so it is clear that this is coming out as ambiguous because neither f1 nor f2 has a better conversion than the other in all the arguments. Basically, it's not like, you know, it's one of them is better. Okay. Now consider the second case where you have int double here and you have int double here. Okay. Okay. So F1 is int double and F2 is int double. Okay. Now, in this case, F1 actually wins. Okay, so there is no ambiguity, or in this case, there is no ambiguous function call. Okay, why is that? Because in the second argument, okay, F1 is actually a better conversion because it is an exact match. So the input is int and the formal argument is also int. Okay, so the parameter is provided is of type int and the formal argument is also of type int. Okay, so there's an exact match here. Okay, but F2 there is a conversion. Okay, so it is worse. So F2 is worse in the second argument. Okay, in the third argument, both of them are conversion. And in the first argument, both of them are exact match. So they are equal in terms of the first argument and the third argument. But in the second argument, F1 is winning. Okay. So that is why F1 is the clear winner. So there is no ambiguity here, or the compiler doesn't say that this is an ambiguous function call. So I hope this becomes clear,
Sir?
right? Yes.
Sir, if it was FUN of 5.0, 5, would it be still F1 winning, or would there be some ambiguity? Because the first argument is int in both. So
yes. So anybody wants to answer that question? So the question is, if it was fun double int, let's say.
Even then, I think F1 should win.
Yes, so even then F1 will win. Why?
Sir, because for the first and third arguments, like both the functions are similar. So
Right. So for both first and third argument, it is a conversion. Okay, so for the first argument, it is a conversion from double to int. For the third argument, it's a conversion from int to double. Both are conversions, and like we discussed just a while back, that both of these are considered conversion, and for reasons, I mean, both of these can lead to data loss. So these are all considered, to be precise, these are considered standard conversion. Okay, so all these are standard conversions. Okay, promotions are the following. So promotions are better than standard conversion, but still they are worse than exact match. Okay, so so remember, even if there is a promotion, so for example, if there is a promotion from cat to int where there is no data loss, okay, still exact match will be considered better than a promotion. Okay, so this is another point to consider. Okay.
Sir?
Yes.
So like just confirming it once. So like suppose if there are two promotions and there is one exact match. So the one exact match one will be preferred, right, sir?
So see here the count is not like that, right? So see again, read this very carefully. So this is actually a tricky idea. Okay, so it is saying for every argument, okay, so it will evaluate. Okay, if so for example, I will give you another example. Okay, so so suppose here there were 4 arguments. Okay, int and double. Okay, and then in the input 2 of them were int and 2 of them were double. It is not that one of them will be considered better. Okay, it is not the count that matters. Okay, so what matters is that one of the conversions in all arguments has to be either better or not worse. If no such conversion is found, then basically it is ambiguous.
Yes, sir. Yes, sir. So like suppose if f1 was instead of int double, if it was in the second case, the int double f1, if it was long int double, then it would be ambiguous, right? Because even though for first variable f2 has a better match, the second variable f1 is better than f2, so it wouldn't be preferred.
So the second one is better than, yeah. So in the first, so if I understand correctly, what you are suggesting is that the f1, the function f1, okay, that is being changed to something like a long double, right? That's all the
Yes,
thing
sir.
you are changing, right?
Yes, sir. Yes, sir.
Okay. So in this case, you see, for the first argument, there is a promotion for f1. Okay. But there is an exact match for f2, assuming that 5.5 is like, which is taken as int. So normally 5, the integer literally is taken as int. So hence, in the first argument, f2 is actually better than f1. So this will come as ambiguous.
Yes, sir. Got it, sir. So it should be better in every argument or equal.
Better or equal in every argument. Yes. Yes.
Yes, sir. It's clear now.
Sir, in the example 1, for 2.0, if here the double conversion is not worse than exact match, is it?
Sorry, I couldn't understand your question. Can you repeat?
So here we called 2.0.
Okay.
So here the 5 is integer and we are converting into double.
Yes.
So can we say that it is not worse than direct exact match?
No, it is worse than exact match. See the
ambiguous.
Sorry, I'm not able to hear. See, it is worse than exact match. So conversion, any conversion is worse than exact match. So for example, 5 converting to double is worse than exact match, where 5 is actually an int and it gets taken as int. Okay.
So what I'm saying here is that here we have 2 exact matches and 1 conversion for the F1.
For the F1, yes.
And for the F2, there are 2 conversions and 1 exact match.
Yes.
So how shall we compare?
The count doesn't matter. It is ambiguous because neither F1 is better than F2 nor F2 is better than F1. There are arguments for which F1 is better than F2, and there are arguments for which F2 is better than F1.
Okay.
So the count of anything doesn't matter. Okay. So argument wise, so the compiler goes argument wise and compares whether one is better than the other or not. Okay. So I think this is clear. So this kind of concludes our function overloading. Okay. Any other questions on function overloading?
Sir, let us say we have 2 different types of promotions for while comparing. Then are those promotions like compared within themselves? Like let us say we have a promotion from int to float, and in another promotion we have int to double. Then in priority they both will be treated equally, right?
Yes, in priority they will be equal. Yes. So there
within
are
different promotions we are not making any comparison.
See, let me just explain this. So see, there are these 4 stages. Okay, there is exact match. Okay, there is promotion. Okay, there is standard type conversion, and then there is user defined time conversion. So all exact matches are same, all promotions are same, all standard type conversions are same and all user defined type conversions are same. Clear? So there is no,
Yes.
one is not better than the other.
Okay, sir. Thank you.
So, sir, it would be ambiguous.
No. So when will it be ambiguous? It will be ambiguous if in no argument one is better than the other.
Sir, I'm
So for-
asking for the previous case. One previous case, if everything is same except one argument where one is promoted from integer to float and the other one is to double. In that case, would it be ambiguous?
Yeah, it will be ambiguous. Yes.
Okay, sir.
Okay, so you are saying that there is only one argument and integer one. And there are two which are float and double. So there are two prototypes which are float and double, right?
Yes, sir. No. I mean, there can be many arguments, but a single one is different.
So then whether it is ambiguous or not, it will depend on what the other arguments are.
Yes, sir. So all arguments are same except one.
No, what do you mean by all arguments are same? Okay, so for between two functions, all there are other arguments, but all other arguments are of the same type.
Yes. All are of the same type, and the
Okay, so
one of
in the same case, so it will be ambiguous. Yes.
okay.
So, yeah. So yeah, it will be ambiguous. Yeah, because it is not that in the other arguments also they can win. One call can, the call can beat one over the other, and it is ambiguous in this case also. Okay, so okay, so any other questions? Okay, so we stop function overloading and we now start with so we start with operator overloading. Okay, so yes.
Sir, could you please explain what is user-defined conversion?
So conversion to user-defined types. So one simple. So we have not seen classes yet, but one simple way of doing user-defined types is you can. Where is it? So you can use struct. Okay. Clear. So you can use struct to define types, right? So conversion to any user-defined type. Yeah. Okay.
Okay, sir. So it's conversion between two different definitions of structs.
Yeah, actually, you cannot do. So let me hold on to that. Okay, actually, you cannot do conversion to struct. Okay, so maybe enum you can do. So there is a default conversion from int to enum. Okay, but you will see that there can be conversions. You can define conversions when you define types using classes. Okay, we have not gone there, but you will see that in C++ essentially. So this is actually one of the main features of C++, that you can define the user can define types. Okay, and these types can have everything. You can they can behave just like a built-in type. So they can have their own operators, they can have their own conversions, their own initialization, etc. Okay, so so conversion to one of these user-defined types is the least priority. Okay.
Okay, sir.
Okay. Okay. So let us go ahead with operator overloading. Okay. Okay. So okay. So what are the so what is an operator, right? So so in C you must have seen many operators, many types of operators, which are like, so there are arithmetic operators, there are comparison operators, there are assignment operator is there, okay? Then there are bitwise operators and so on and so forth, okay? So there are many different operators in C. But not just that, so you will remember that size of is also an operator. So it doesn't have to be a symbol also. There can be words which are operators, okay? So these are like keywords in the, so operators are defined as keywords in the language, okay? So keywords, as you know, you cannot have names, okay? So okay, so now the question is, from a programmer point of view, okay, you can achieve something by using an operator or a function, right? So in C, you would have seen that, like, so you can take this example, for example, okay? So here you are having multiply, okay? And you are taking two unsigned integers, okay? So, and you are not using the star operator, but you are achieving multiplication between two unsigned integers, and the output is another unsigned integer, okay? So the first line here, okay, is using the star operator, and the second line is using the multiply, okay? So they are achieving the same functionality, right? So both of them are achieving the same functionality, okay? So as such, from the programmer point of view, there is so can someone say what are the differences between operators and functions? Okay, so let us go ahead. So here is a comparison of kind of the main differences between the operators and the functions. So the main difference is that the operator is usually written in the infix notation. So what does it mean to say infix notation? So for example, consider this binary operator, which is plus, okay? So then the operator, the expression a plus b, so if you were to be able to achieve this functionality of a plus b, okay, you will have to write it as plus or addition of a comma b, right? So the two arguments come after the operator or operation that is happening. In this case, the operation is actually a function, okay? So this is called the prefix notation, okay? So where you first have the the operation that is going on, and then you have all the operands, okay? But in operator, it is in infix notation, okay? Okay, and so operator can operate on one or more, usually up to 3 operands, okay? So you can have unary, binary, or ternary operators, okay? So for example, plus plus is a unary operator. There are two plus plus operators, prefix and postfix, okay? Plus is a binary operator, equal to is a binary operator, and so on and so forth, okay? And so on. Yeah. So in function, there is no sort of restriction on the arity, okay? So you can have 0 or any number of arguments, okay? So so this is the difference between, this is another difference, okay? Operator generally produces one result, okay? Function may not produce any result. So the return type of function can also be void, okay? Then so because operators are written in infix notation, you need the, if you remember, you need the precedence and the associativity to actually resolve things like, A plus B plus C or A plus B star C, how, how the bracketing will be done. Okay. Whereas in function, it is simple. So it is depth of nesting. So you can have the output of one function as, as input argument to another function. And in that case, the nesting depth, the deeper function will actually be executed first. Okay. Okay. Yeah. Now, the other thing is that operators are predefined in the language. Okay. But you can define new functions. Okay. So these are the differences between operators. Okay. Now in C++, so the one thing to understand here is that underlying most operators, not every operator, but most operators, we'll see some of the differences. Underlying most operators is also a operator function, okay, which achieves the result that that operator says, okay, is achieving, okay. So in C++, so in C, you could not access these operator functions, okay. But in C++, since C++ allows polymorphism, okay. So and as a part of the polymorphism, okay, it also allows operator overloading, okay. And what does that mean? It is, the concept is same as function overloading, that depending on the type of the argument of the operator, okay, a different version of the operator may be called, okay. So how does this happen? So for this, C++ introduces this keyword called the operator keyword, okay. And the operator keyword followed by the actual operator signifies the operator function, okay. So so here we have given some expressions and the corresponding operator function version, okay. So for example, A plus B, where A and B are two variables, you can the operator function version can be operator plus A comma B, okay. And similarly, you can see so many others. So you can
So
say
if you
A,
find operator plus A comma B comma C, then will it add all?
if you write operator plus A comma B comma C, it will give an error.
Okay, sir.
Okay. But you can write operator plus A comma, again operator plus B comma C. Okay, that you can write.
Okay,
And
sir.
that is how that is how the expression is also evaluated. If you see, it is evaluated using bracketing. So if you write A plus B plus C, then B plus C is first evaluated. I mean, depending on, yeah. So B plus C is, yeah. So I think, B plus C is first evaluated and then A plus the result of B plus C, something like this. Okay. 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 So now, okay. Yeah. So these operator functions are implicit, okay, for predefined operators on built-in types, okay. So for example, the operator plus, when the argument type is int, is predefined, okay. So you cannot redefine that, okay. Okay, so these are all predefined and you cannot redefine that. What you can do is you can overload the operator plus for a newly defined type. So mostly in C, you could use an enum which defines a new type, or you could use struct. Actually, you could use type def and then struct to define new type. Okay. So these are the ways of defining new type in C. In C++, actually struct also defines a new type, so you don't have to use type def. Okay. Yeah. So so you can say something like so suppose you have defined a type my type, then you can define variables of type my type A and B. Okay. And if you have defined the operator function like this, my type operator plus my type comma my type. Okay. Then you can call something like A plus B, and it will call the body of this particular function operator plus. Okay. So basically, so C++ allows users to define an operator function. Okay. And since operator function is like any other function, you can also overload the operator function. Okay. 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 So so here is an example of how you can use the operator plus to actually do string concatenation. Okay. So so in the left is a normal string concatenation code. You can see it for yourself. I'm not going over it. In the right is the operator version of that. Okay. So here what you do is you define a new type using this type def struct string char star and then string. Okay. So basically this is a pointer to the string. So this is just one way. You can have many ways of doing string class. Okay. Now you can say string operator plus const ampersand string const string ampersand s1. Okay. And const string ampersand s2. Okay. And then basically what you are doing is you are allocating the memory for the new concatenated string here. Okay. Then you are first copying the string onto the newly allocated string. Okay. Newly created string. And then you are concatenating the second string. Okay. And then you are returning S. So this will have the same effect as string concatenation. So then you can say in the main function you can say string fname, lname, and then name, and then you basically initialize the string fname and lname. We will see much better ways of initializing once we see classes, but for the time being you just use strdu. Okay. And then you can simply write name is equal to fname plus lname. Okay. And it will call this particular function, which will create a new string. It's not an object at this stage because so it will just create a new structure of type string, and it will also allocate the memory because the concatenation operator here is allocating the memory. Okay. And then it will just return the so basically then you can just print first name, last name, and full name, and if your input is Partho and Das, then your full name will be Partho space Das. Okay. So I hope this example is clear. Okay?
Sir.
Yes.
Sir, in the operator plus function, we are declaring string s as a local variable, right? So how can
string s as a local variable? Yes.
Sir, so how are we returning it by value? So won't the memory be deallocated after the call is returned to the main function?
Very good question. So anybody wants to answer that? Any of the students?
So the memory allocated here is dynamic allocation. So it is allocated to heap. So that's why it doesn't get destroyed while the function scope is over.
Right. So you see, S is a structure, okay, and it only has a pointer. Okay. the actual memory is dynamically allocated. Okay, so the basically when you return a a structure by value, each of the field is copied to the return type. So this particular pointer will also be copied to this structure, which is name. Okay.
Okay, sir.
Okay. Okay. So so this is another example of operator overloading. Okay. So here what we are doing is so we are having this enum type, okay, E, which has basically 3 values. Okay, so C0, C1 and C2. So okay, and now you want to define the so so we want to define a plus operator on this type E. Okay, so how do we do it? So basically if we just use the standard plus, you know that basically C0 will be so any enum type is mapped to int. Okay, so in the left if you see this, it will, so A plus B will produce actually 3, okay, which is not an enum, which is not of type E. It is not an object in the enumerated type. Okay. So you want to, let's say, define the plus operator such that it always returns something of type E. Okay. So here is the definition again. So what you can do, you can basically take the integral values of them, and then you can output the modulo 3. So you can add them and then do a modulo 3 operation. Okay. So if you do that, so if so the result then will always be 0, 1 or 2, because the remainder of division by 3. So basically you always get, and then you cast it of type E again and return. So you will always get type E, the output is always of type E, and for example in this particular case you will get 0. Okay, so this is I think you have seen already fields, right? So this is, for example, one way of implementing a finite field arithmetic, right? So
Sir,
yes,
here there will be already some default function, right? So we are overloading here. So won't there be any ambiguity?
Right. So that is what overloading does, right? So why is it called overloading? See, there is obviously a default plus, which is why the left-hand side code is working here, right? But you see here, there is no ambiguity because the input type is of type E. So there is obviously a mapping, a mapping from E to any enum type actually to integer. Okay, there's a conversion from any enum type to integer. Okay, but the exact match will be of type enum. So here is no ambiguity, right? Because this variable A is of type E. Okay, so there is an exact match with this particular definition of the operator. If you pass integer, okay, then it will take the integer version. Clear? Am I able to answer correctly?
Sir, I didn't.
Okay, so suppose you define here int, let's say C comma D, okay, and then you say y is equal to C plus D. So there are 2 versions of the operator plus operating in the second program. Okay. So in the second case, the default version which works on integers will be called. Is this clear?
So here already the data type of A is E, we can just overload it. So
Yes,
that there will be no conversion into int.
No, but conversion to int is, if there is an exact match, then the conversion doesn't matter.
Okay.
Right. Okay, so it doesn't go to the conversion stage. Okay. Okay. Okay.
And
Yeah.
sir, here you are, the return type is E, but X is an integer.
Sorry?
Sir, in the operator plus function,
Yes.
the return type is E.
Yes.
So can we simply convert X and E into each other?
We can convert, right? So you can do, right, take this case, for example, see return, I'm casting this, what is the type of this variable t, right? It is an unsigned int type, okay? But I'm casting it of type E and returning. So conversion from E to unsigned int and unsigned int to E is possible. I mean, all other conversions are also possible, but in particular, this particular conversion is possible. Okay.
Okay. Yes.
Okay. Okay. So yeah. Okay. So so what are the rules for operator overloading? So you cannot define new operators. Okay. So you can only have a predefined set of operators. Okay. New operators cannot be defined. Okay. You cannot change the arity, precedence, or associativity of an operator. Okay, so they remain exactly the same. Okay, you can only define the exact operation that takes place. Okay, now here is a list of operators which can be overloaded. You can see that there is a large list of operators which can be overloaded, and it is up to the programmer to properly use this. Okay. Now, yeah, so the special thing is that for the plus plus operator, it can be both a prefix. So it can basically be so it can be a prefix or a postfix operator. So if you want to overload the postfix version of this operator, you overload it like this. Okay, so my type operator plus plus my type ampersand S1. Okay, and comma int. Okay, so this second dummy argument int, so this argument never gets used. Okay, because only the operator plus plus is a unary operator, so it gets only one argument gets used. But which version of the operator to overload gets decided by whether the overloading prototype is of the second type or the first type. Okay, and there are many operators like the scope resolution operator, the member access operator, okay, the member access through pointer operator, size of operator, ternary operator, etc. These cannot be overloaded. Okay, and if you overload the ampersand operators, then the short circuit evaluation property gets lost. Okay, so this is another thing. Okay.
Sir, can you explain that unary postfix again? Why the dummy argument is required?
Okay, the dummy argument is required to differentiate between the prefix and the postfix plus plus operators.
And why only int? Shouldn't we give float or something?
It's just a convention. So this is what the compiler recognizes. So somehow you have to give two different prototypes. Okay.
Okay, sir.
So like one thing that might have difference in other thing that might have
Yeah, I'm not able to understand. There is some sort of a garbling.
Sorry, funding has made it interesting. Topics have made it interesting.
Sorry, I'm not able to understand. Can you do the following? Can you just type in the question? Okay. Because yeah, please type in the question here so that because I'm not able to hear. I don't know if somebody else can hear, they can also translate the question.
Sir, I had another doubt.
Okay.
Sir, all the examples in which you gave for operator overloading, there were only 2 parameters in the function. So like, can't we have operator overloading for 3 arguments?
Yeah, so the only ternary operator is, if you see, is this question mark colon. I mean, basically the conditional operator it is called, right? And that cannot be overloaded. Yeah, so yeah, I'll just come to that. Let me, I'll come to that in a minute. Okay. Prefix has ampersand, but postfix doesn't have ampersand. What is the difference? Okay. This is yeah. This is just a typo. I mean, you can have it really depends on what you want to return. Okay. So if you want to return a reference, then you have ampersand. If you want to return by value, then don't have ampersand.
Professor Shorangshu.
Yes, sir. Yes.
When you do a prefix operation, you
Yeah.
you are actually incrementing the value and returning a new object because it's an incremented value. Whereas in a postfix, the postfix is a side effect because what you return is the original object.
Right.
So in postfix, you have to return it as a reference. Otherwise, you'll get a copy of the original object, which is just not what you want. Whereas in a prefix, you want a new object because it is an object with the incremented value.
Right.
That is the basic difference.
Okay. So here we should be returning. Oh, okay. So the operator does that. Okay, got it. Yeah. Okay. So there is no reason to explicitly say ampersand.
Right.
So I hope that explanation was clear, right?
Sir, but whether to use it as prefix or postfix, does it depend on the data type, return data type? For example, if I want for a particular structure, the postfix operation operated on any structure would return the integer 0, and the prefix operator on any structure would return the integer 1, regardless of what the structure is. Then also, like, I can define the return types to be int. Right? Will that work?
Yes, so return type is anyway not taken care of while choosing the. So are you asking that which version of the operator will be called?
Yes, I'm asking that whether the return type has any effect on which version will be called.
No, right? So that is never the case. So just like function overloading, in function overloading also the return type did not have any effect.
Yes, sir.
Here also it will not have any effect.
Okay, sir. It's similar, sir.
At the time of calling, if you call it as a prefix operator, like if you say plus w, let's say w is the variable. So plus w will call the prefix version. W will call the postfix version.
Okay, sir. Yes.
So do we need to return? Like it won't need to return, right? As we are sending the ampersand, like reference to the variable, it can increment it. So are we returning something?
No, so actually what Professor PPD said, maybe I will just explain it a little bit more. See, basically, you have to return in case of prefix, you have to return by ampersand because the operation that you perform inside, okay, has to reflect outside the operator function, right? So you have to return by reference because what you are doing. So think about it like this, that if the function, you define the function like this, that this S1 variable inside the function, if you do S1 is equal to S1 plus 1, let's say. Okay. So this is, or let's say plus plus you want to increment by 2. So you say S1 equal to S1 plus 2. Okay. Now this has to reflect when the operator has stopped working. Okay. That is why you have to return a reference to S1. Clear? But in case of postfix operator, the return value is not the, so there may be something that happens. So suppose you do S1 is equal to again S1 plus 2. Okay. So S1 will be incremented by 2, that is fine. But the return value of the expression is the original value of S1. So hence, in this case, you need not return by reference.
Okay, sir.
Sir, means how will returning by reference help? Because anyways, the changes made are being reflected in the main. So like if we do prefix or postfix, we have to reflect the changes back in main. So changing the return type, how does it, is it exactly helping? I'm not able to understand.
See, let me explain it a little. See, get few things very clear in your mind. Operator functions are functions, but they are operators in the fact that they must return a valid value because they can be used in an expression. Right? That's the first thing. So the second point is, if you are doing a prefix operator, then what is that value that you expect after you have applied the prefix operator? You expect that value to reflect on the same object on which the operator was called, right? So you need that same object back. If you return it by a return by value mechanism, that is just my type, then what you will get is a copy of the original object on which your actual operation happened. So in the expression where you are using, you will now be using now a different object than on which you had called the prefix operator. In case of postfix operator, you are doing the postfix operation on the original object on which you have called. That is a side effect. And you want the original object to be returned. That original object is not same as the current object because current object has been incremented, right? So you want the value of the original object to be returned. So the original object is different. So you have to keep, when you do this postfix operator, you have to keep a copy of the object on which it was called and return that copy back. So that is a temporary copy. So you will have to return it as a value so that you get a copy of the original object. You do not get back the original object. The original object has changed, right? This is the difference in the actual semantics of the prefix and postfix operators, right? So you'll have to keep that in mind. Okay, and the return type for every operator is very important because the operator will be used. Any expression with an operator, anything you do with an operator becomes an expression. So it has a value. And that can be used again in some expression. So unless it has a well-defined return type, which should be proper, you will not be able to use it again. Right? That is the basic reason. Does that clarify?
Yes, yes, sir. Okay, thank you.
Okay. Okay. So yeah, so certain so there is just last few things. So I know you are already late. Just let me finish this because next class we can start different topic. So certain operators cannot be overloaded. Okay, so we have already mentioned. So for example, the dot operator cannot be overloaded. Okay, and the reason is that the second argument, you see, for the dot operator or even the dot star and arrow operator and all these indirection operators, the second object is a name basically. So the second argument is a name. Okay, in case of dot operators, it's the name of the field or the member function that you are referring. That is why it is not allowed to overload. Okay. Similarly, the scope resolution operator, again, you see the first argument is a namespace. Okay, and the second argument is a name. Okay, so namespace or scope. Okay, so that is why you are not allowed to overload it. Okay. Again, in case of a ternary operator, you cannot overload it because you cannot guarantee that only one of the arguments will be evaluated or one of the arguments will be executed. Okay. Yeah, and similarly, size of is again something that you use. It's a built-in operator, and it's used in many internal functionings of the compiler. So hence, size of cannot be overloaded. Okay. And again, yeah, so we discussed this, that ampersand. So if you see the logical operators, okay, you should not overload it because you're basically short circuiting. So you know that in ampersand, if one of the operands turns out to be, let's say, false, then the other operand is not evaluated, and vice versa for the OR operator. Okay, so so these kind of behaviors will not be replicated. Okay. Similarly, for the comma operator, you cannot ensure that expression 1 will be evaluated before expression 2. Okay. Yeah, and also ampersand operator, also it doesn't make sense to overload the ampersand operator. Yeah, because so basically yeah, so what happens is that so you can take like something like an object of an incomplete type. Okay. So actually we will discuss this when we discuss classes. Okay. So but yeah, so it will lead to some inconsistent situations in your programming. So it's better. I mean, it's suggested that you should not overload these operators. Okay. Okay. Yeah. So any questions? So that concludes our discussion on operator overloading. Any questions?
So I had a question on the prefix and post plus operator.
Yes.
So like when we call it in the main like S1 plus plus, so why does it why does it chooses the postfix function over the prefix?
If you say plus variable, why does it choose prefix over postfix?
Like when we say S1 plus plus, why does it chooses postfix over the prefix?
Because that is by definition, right?
But like, how do you define that? Like in the functions in defined, we cannot see that one will be given preference.
Nothing actually is being given preference. We will show you how the infix notation. See, when you are writing X is an object. You are writing X plus plus or you are writing plus plus X. These two infix notations are converted to prefix notation of function. That is operate X dot operator plus plus. So if it is plus plus X, it becomes X dot operator plus plus just bracket. And if it is X plus plus, then it becomes X dot operator plus plus within bracket int. Right? So that is how it differentiates. It's not a question of preference. You are explicitly saying which one you want.
Yes, understood.
You have said that in the infix notation. Now this has to be mapped to the prefix notation. That is the reason that dummy int argument type is used in the postfix operator signature. Okay, that is the translation.
Yeah, so it's not like which operator is used. That is not the so at the time of writing the program, you are choosing which operator to use. Okay, so there is no confusion there.
Yes, I understood now.
Okay, okay, okay. So
Sir, a small doubt, sir. When we write my type and, so isn't it sending a reference to the new object?
when you are writing my type ampersand, the return is by reference. So yeah, so whatever you define, whatever you return, that return is by reference.
So sir, in the prefix operator also, we can return without ampersand.
No, you cannot. You cannot. Because in the prefix operator, you expect the same object to be back. That is the semantics. In the prefix operator, you expect the same object to be back. That is the specification of the language. Right? And in the postfix operator, you want the increment or whatever operation, postfix operation you are doing to happen on your calling object as a side effect, and you expect the original object to be back. So these two semantics are different. Right?
So sir, let us say I want to write my own function operator plus plus operator function plus plus, then I have to follow this exact same prototype, right? Otherwise the compiler will give error for both prefix and postfix.
The compiler will not give error, but the entire programming community will not understand what you are doing. So it will be a very bad practice.
Okay, sir.
Because when I will read your program, I will expect that this is the language specified syntax that you are following. So, but you are not doing that semantics. So I will get confused. So it will become a very bad programming style. See, the compiler cannot give an error because you are defining it on your type, which was not known to the compiler. So compiler does not know what you are trying to do. So compiler cannot give an error. But as a programmer, you will not do this. Right?
Okay, sir.
Okay, sir.
Okay, so any other question?
Sir, can we do something like default parameters in operator overloading?
Can we do something like I don't think it makes sense. It doesn't make yeah, so yeah, so it doesn't make sense, right? Yeah, so I don't think you can use it, because if you let's say provide default parameters, but when you are using that overloaded operator in the program, you have to provide, let's say it's a binary operator, then you have to provide both the operators.
Professor Shoramshu,
Yes.
the question, it's a tricky question. Whether or not you can have default parameter depends on whether your compiler defined operator has default parameter. Right. So for example, if you look at new operator, you can have default parameters there. It does have default parameters.
Okay, so then
so you go by what the standard operator signature is, and then you use it for your type. Don't do any innovation on that, because that will always mess up the program.
Yeah, the program will be messed up. So basically, even if so at the time of definition, it may happen. Okay, it may not give any error, but at the time of usage, what you will do is, so suppose you're defining the plus operator, right? So you will always supply the second argument, because otherwise at the time of call your program will not compile.
Okay, sir. Yes, understood.
So yeah, so basically you will end up always using the non-defaulted version.
Okay, sir. Thank you, sir.
Okay, any other questions? Okay then, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.